Now suppose body is rotated with a velocity greater than critical velocity. So here I am taking the case of greater than critical speed. If a body is rotated along the vertical circle, let us say radius of the circle is r. A body is rotated along the vertical circle with a speed greater than critical speed. At that instant, let us suppose velocity at the highest is not Lg, let us take root xrg. A velocity at the highest point is given as root xrg. Then what is the possible velocity at the lowest? When here the velocity is root rg, root Lg, here we got as root 5 Lg. So 5 can be written as 1 plus 4. So I can imagine it as x plus 4 rg. If the velocity at the highest point is root xrg, then possible corresponding velocity at the lowest is root x plus 4 into rg. In the similar way, at the horizontal position, the same thing becomes x plus 2 into rg. So while solving the problems, this is very important. Apply the law of conservation of energy, you can prove these values. But remember, root xrg is the velocity at the highest, then at the lowest it becomes root x plus 4 into rg, at the horizontal it is root x plus 2 into rg. In the same way we can define the critical tensions also. If the body is rotated with a speed greater than critical speed, then possible tensions. If the tension at the highest point is, let us say, instead of 0, it is nmg, where n value greater than 1. Any value 1, 2, 3, 4, etc. I am taking n is equal to 1, greater than or equal to 1. Previously it is 0. Then here we got as 6 mg. So here it becomes n plus 6 mg. The horizontal position it becomes n plus 3 mg. So when the body is rotated with a speed greater than critical speed, these are the speeds at different points and these are the tensions at different points. Now let us consider the kinetic energy. What is the minimum kinetic energy required for any body to complete the vertical circle? So we know that minimum energy, kinetic energy is at this point, let us take lowest point. It is half mvl square. So half m into VL is already we know 5gl. Therefore, it is 5 by 2 mgl. This is the lowest point minimum kinetic energy. At this point, potential energy is 0. Therefore, total energy is equal to kinetic plus potential, which is equal to 5 by 2 mgl or mgr if r is the radius. So for any body to complete the vertical circle, it requires a minimum energy of 5 by 2 mgl. Without this minimum energy, it is impossible for the body to complete the vertical circle. So it always requires 5 by 2 mgl kinetic energy. This is said to be the minimum total energy required. At the lowest point, it appears as kinetic energy. This total energy is kinetic energy at the lowest. This value is 5 by 2 mgl. Now suppose a body is allowed to slide down, let us say, from the top of a smooth inclined plane of a height h. So from the top of this plane, a body is allowed to slide down and it is going to touch the vertical circle. The bottom is touching the vertical circle. Let us say it's arranged like this. A body is allowed to slide down from the top of a plane of a height h, and this is the body position. After reaching this lowest point, now a body moves along this circle. Let us say radius of the circle is r. Now I want to calculate the relation between h and r so that this body completes this vertical circle without any problem. Then what must be the minimum value of h? So let us apply law of conservation of energy. Let us take total energy here as Te1, total energy along the vertical circle as Te2. We know that law of conservation of energy suggests Te1 must be equal to Te2. What is TE1, which is equal to mgh? TE2, we know that 5 by 2 mgr. If the body has to complete the vertical circle, the minimum energy required is 5 by 2 mgr. So if I cancel these terms, mg on both sides, then h becomes equal to 5 by 2 r. If h value less than 5 by 2 r, impossible to complete vertical circle. Body cannot complete vertical circle. If h greater than or equal to 5 by 2 r, completes. Happily body completes the vertical circle without any problem. It moves along this vertical circle. So the minimum condition is h is equal to 5 by 2 r, so that body can complete the vertical circle after reaching this bottom. Here we are assuming the plane as smooth plane, no friction is present.